Tekken 5.
Dive into Python with a fun game, learn in just 5 minutes. Welcome back. After building our Tetris game in the previous tutorial, today we're set to enhance it further with Python and PyGame. We'll be adding an information area, a dynamic score system to track achievements, sound effects for engaging gameplay, and animations to bring our game to life. Whether you're starting your programming journey or you're an experienced developer, these upgrades will not only add excitement to our Tetris game, but also enrich your understanding of Python and PyGame. So, let's dive back into game development and elevate our Tetris game to new heights. First, we introduce a next Tetramino preview, a feature that adds strategic depth to gameplay. The info area class handles this by generating and storing the upcoming Tetramino. Within our main game, we draw this next piece in a designated area using the drawInfoArea function. When a Tetramino lands, we pull the next one from info area. Simultaneously, info area generates a new Tetramino, ensuring a continuous flow of gameplay. Next, we're adding sound effects to enrich the player experience. Using PyGame's mixer module, we introduce distinct sounds for key moments. A cork pop when a Tetramino lands, and a bell chime as rows are cleared. These sounds will be triggered in our game loop. Enhancing our Tetris game further, we introduce a dynamic scoring system, where players earn points for clearing rows, and these points determine their level progression. The info area class tracks the score and level, increasing the level every 100 points. We visually represent the player's progress towards the next level through a custom-designed progress bar in the drawScore bar function. This bar fills proportionally to the points accumulated within the current level and is bordered for clarity and emphasis. As players clear more rows, particularly multiple rows at once, they gain more points, filling the bar faster and advancing levels, which gradually increases the game's challenge. This escalating difficulty is implemented by decreasing the drop time as the level goes up. In the info area class, each new level achieved reduces the drop time, upping the game's pace. Starting from an initial 500 milliseconds, the drop time decreases by 50 milliseconds with each new level, down to a minimum of 100 milliseconds. This mechanic ensures that as players become more proficient, the game responds by providing a greater challenge, keeping the gameplay engaging and continuously testing their skills. Also, we visually represent each level achieved by the player, using circular badges. This is achieved through the drawBadges function. Given that our badge images are square, we employ a masking technique in PyGame to display them as circles. First, we create a badge mask surface with the same dimensions as our badge image. On this mask, we draw a circle that defines the visible area of the badge. By blending the square badge image onto this mask with the blend RGBA mult flag, only the circular part of the image within the drawn circle is rendered. This technique effectively crops our square image into a circular badge. The drawBadges function then iteratively places these badges on the screen, organized in rows and columns. For each level, the function calculates the appropriate X and Y coordinates, based on the badge size and spacing. This approach utilizes PyGame's surface and blending capabilities to create more complex and visually appealing graphics. To enhance further, we introduce animation to level up feature, adding a visual reward for player progress. When the player achieves a new level, the Start Level Up animation method in info area is triggered, setting level up animation to true and initializing animation_frames to 30. This indicates the start of an animation sequence that will last for 30 frames. In the drawBadges function, we create a dynamic effect for the newest level badge by controlling its visibility. During the animation, this badge flashes, appearing and disappearing every few frames. This effect is achieved by drawing the badge only when animation_frames divided by 5 equals 0, creating a blinking effect. The continue level up method, called within the game loop, decrements animation_frames by 1 each frame. Once animation_frames reaches 0, the animation concludes and level up animation is set to false, ending the sequence. Now, let's enjoy our game.
Stay tuned for more videos on Tekken 5.